So if I think about it, the number one thing which I can think of your phone can have or needs to have an information is broadcast information. So let's write it over here. Broadcast information. That's number one. What else do you think a phone can have or we can receive? Another type of information is signaling, because your phone needs to have control signaling being received from the e-node and core network. So let's write it over here as signaling. And if we are talking about RAN side only, so let's focus more mainly on RRC signaling. If we may, let's write it signaling over here at the moment. Anything else? As a user, we cannot forget that we all want to have application data, because if we all are using all different apps on our phones, there needs to be some data coming for those apps. So let's write it over here, application data, which is the end user or the consumer data. That's another type of data which your phone is receiving. And also, in case, let's say if you're sleeping or you're not using your phone and suddenly your phone starts ringing or you start receiving an email message, what just happened there? Your phone received a paging message. As a result of page, your phone started ringing. So another type of data is paging data. Last but not the least, another fifth type of category of data we want to classify here is multicast information, which, for example, if you're watching a football match on your phone and you're getting broadcast information, multicast traffic. So let's write it over here as multicast information. Now remember, in the previous video we talked about logical channels, and I've said logical channels are those channels which contain the type of information. Depending on how many types of information we have, we need to have those many logical channels. Not necessarily we need to have those many number of logical channels as per how many types of information we have. But you can get an idea that based on different types of information, keeping this particular information, now we have. So this particular information is there. Let's say if we have broadcast information. So for this purpose, for the case of broadcast information, let me label it over here, logical channels specifically. So if we have logical channels to be defined, so for broadcast information we will have a channel which will only carry master information block, system information block, and that channel we have is termed as BCCH, which stands for broadcast control channel. Similarly for signaling, now remember, signaling is not a small word, meaning you can have dedicated signaling, you can have signaling for those users which are not even connected yet. So that will be common signaling. So for this case, when it comes to signaling, we need to have logically two channels. One is common channel, that's why it's abbreviated as common control channel, CCH. And then for those users which are connected, we will have dedicated signaling termed as dedicated control channel or DCCH. Okay. And also we have application data, which we all like and want on our phones. So for application data, we have a separate logical channel which is termed as dedicated traffic channel. We need to have logical. Remember, keep this in mind. We need to process this information very fast in the USB, so that's why these channels are defined, so that they can categorize the information. And then we have paging information. We don't use our phones 24/7. Now, if you are a teenager, you may use your phone 24/7. You are allowed to do so. But apart from the jokes, paging is very important. In case of paging, we have a separate channel which is termed as paging control channel. It carries all the paging information. And finally, for multicast information, we have multicast traffic channel, and then we have multicast control channel, because you need to have multicast traffic which is coming along with additional control information. So we have two different channels over here. So having said that, let's go and draw these different channels which we have defined and categorize them at logical level. So as we discussed, we have, first of all, we have broadcast control channel, and then we have signaling. So in signaling we can have common control channel, and then we can have dedicated control channel, DCCH. In addition, we need to have user traffic, so we have DTCH, dedicated traffic channel. And also we cannot ignore paging, so we will have paging control channel, PCCH. And then we are going to have multicast traffic channel. At this moment in this particular diagram, I'm going to ignore multicast channels for a minute or so, but we do have the multicast picture being drawn in the slides which you have in the course included. Let's categorize these logical channels first before we move on to transport channels. Now, first thing first, transport channels are the channels which are going to process information with certain characteristics. Okay, so we need to get certain things clear over here, or certain things we need to understand. Broadcast information are of two types, and one broadcast information is MIB, which stands for Master Information Block. It needs to be received by all the users, either they are connected or not, if they are trying to get connected, and SIB, which is needed by the users which are connected and trying to get connected. So based on that type of information which we will have different types of transport channels. So let's say we have one type of transport channel which is called as downlink shared channel, abbreviated as DLSCH. Why it's called shared channel, we will understand or get to know this in a little bit. And then we have another channel which is called as BCH, which stands for broadcast channel. And similarly we have another channel which is termed as PCH, which stands for paging channel. And then since I have not drawn multicast channels over here, so if you look into the diagram, you will find multicast channels as well on the screen. Now, your broadcast channel information from the logical aspect, it will come on broadcast channel, and half of the portion will go on to downlink shared channel, as you can see with the arrows I have drawn. So why we have two arrows over here? As I mentioned, we have two types of broadcast information. Your SIBs information go on to downlink shared channel, while your MIB information go on to broadcast channel and transport channel. And then we have DLSCH, this downlink shared channel. Its objective is that it is a shared medium over their interface over which the information will be processed. So your signaling information, those users which are receiving user traffic, they will also receive signaling traffic. That is something which is which you can understand. Any data traffic which is being received, that will also carry signaling traffic along with it. So your dedicated traffic channel as well as your dedicated control channel as well as your common control channel, they all are processed through downlink shared channel. As you can see, I have drawn all these arrows over here. Last but not the least, your paging channel is processed, or your paging control information is processed through paging channel, abbreviated as PCH. Now, someone may ask, okay, why all this information in DLSCH is being mapped onto just one channel? Because any user which will require dedicated signaling, that will require ultimately data traffic as well. So the way that information needs to be processed for the user can be done down in shared channel for processing on the physical layer. And finally, before we jump on to physical channels, let's label them over here. So these are your transport channels. Finally, we need to talk about physical channels over here. So in order to do that, first of all, your user traffic and your actual control signal contents needs to receive on the data portion of the subframe. So for that, we have a dedicated specific physical channel which is termed as physical downlink shared channel. So let me write it over here as PDSCH, abbreviated for physical downlink shared channel. So we have DLSCH coming all the way down to physical downlink shared channel. Now when you are being paged or your phone is being paged, ultimately as a result of paging, either you answer phone call or receive an email, so on and so forth. So the actual paging contents will also be received at physical downlink shared channel, which I have drawn over here at the physical level. And then in addition to that, your broadcast information, which is MIB information, is very important. So we have a separate channel which is called as PBCH, physical broadcast channel, and all that MIB information comes onto PBCH channel, which you can see over here I have drawn. So in this case, so far we have drawn these physical channels. Now there are certain physical channels which are being processed by the MAC scheduler after every 1 millisecond. Transmission time interval in LT is 1 millisecond. So after every 1 millisecond, scheduler process new information on those channels. So for those channels, we will not draw any arrows. And what are those channels? If we think about it intuitively, let's say one of the control information that needs to be processed after every 1 millisecond. So all that control information which is needed by the UEs that comes on a specific channel which is termed as PDCCH, physical downlink control channel, abbreviated as PDCCH. I also call this channel as the spokesperson of the E node B. If E node B wants to convey anything to the UE, it will always come on PDCCH. Similarly, how does a UE know how many UFDM symbols are representing the PDCCH? That will UE will know that information through physical HARC indicator channel, which is also abbreviated as PHICH. So let's draw them over here. Physical control format indicator channel. Let me correct myself here. How does UE comes to know how many UFDM symbols are representing the control region? That information comes through physical control format indicator channel, or PCFICH, which I have drawn next to PDCCH. Once your UE or the phone, it sends anything into the uplink, how does the phone know that whatever has been transmitted in the uplink has been received by the E node B? There needs to be an acknowledgement in this case, and that particular acknowledgement, if something has been received by the E node B, whatever UE sent, that comes on physical HARC indicator channel, which is also abbreviated as PHICH. So having written this, let me write here physical channels. Now keep this thing in mind, guys. This diagram which we draw over here, I have not included the multicast portion. One thing is still missing over here, and what's the one thing? We talked about cell synchronization earlier in a video. So below the physical channels or in the air, we also have synchronization signals, and those are primary synchronization signals, and then we have secondary synchronization signals, and then we have reference signals, depending on what type we are considering here. So let me write it over here as physical signal. So this represents only the downlink portion. We will talk about the uplink portion as well, but this particular mapping of channels, how they are mapped, why a certain arrow is mapped onto a certain portion, that discussion or that information is important to know. Having said that, let's go and take a look at how this actual mapping looks, and whatever intuitions or the assumptions we made, are they correct or not in terms of explaining all this. So let's go and take a look at the same on one of the slides which you have. So now if you take a look at this particular slide, you can see, as we discussed with our intuition, we have broadcast information, we have signaling information, we have application data, paging and multicast traffic, and all those channels, logical, transport and physical, have been mapped over here. And you can see there are certain channels which are not placed with any arrow, as you can see over here, these ones. The reason there is no arrow coming down on these ones is because MAC scheduler, as I mentioned, is giving new information to them after every 1 millisecond, or with each TPI the information on them would be new, so they are always in the air or on the physical channel, and information is being carried through them. Now, important thing, as I said, the structure of these channels is important, or the key component of understanding the downlink air interface. Now the question which should come into your mind is, okay, well, Azhar, tell us how these channels are used when I power on the phone, how these channels will help my smartphone to get connected. We will talk about the usage of these channels, but in order to do that, we need to understand the uplink portion of these channels as well, the logical, transport and physical channels in the uplink. And in the coming videos, we are going to discuss how these channels are used when you power on your phone.